Okay, so in this next video, what I'm going to show you is how to actually write this factorial function where you just count the odd numbers, how you can write that in terms of the normal factorials. Okay, so it's easier to start with the even factorials and then basically just divide the normal factorial by the even factorial. For instance, if I wanted 1 times 3 times 5, what I could do is take 5 factorial and divide it by 4 times 2 basically. So the even factorial. For another example, if I wanted 1 times 3 times 5 times 7, the odd factorial for 7, then I could take 7 factorial, which is just 7 times 6 times 5 times, oh dear, what am I doing? 4 times 3 times 2 times 1, and then divide it by the even factorial, 6 times 4 times 2. Okay, so let's first work on how to get these even factorials, then we can just have the normal factorial divided by the even factorial, 1 less, basically. So just take your odd number, subtract 1 off it, take that even factorial and then divide through by it. Okay, so how could you get this even factorial? One way to do it basically would be to take the normal factorial, 3 times 2 times 1, and all of these numbers here, are twice these numbers here. So if we multiplied this by 2 here to take this up to 6, if we multiplied it by 2 again to take this one up to 4, and multiplied it by 2 again to take this one up to 2, which overall means multiplying this by 2 to the power of 3, that will turn it into the even factorial basically. So if you want n even factorial, so let's say n is an even number, so n is an even number. So let's say in fact, let's let 2n be equal to an even number. So n is just a natural number. Okay, so 2n is an even number. So if you want 2n even factorial, and I don't actually know what the symbol for even factorial is, but I think you might put 2 exclamation marks. We'll just put, in fact, let's, I don't want to use incorrect notation though, so let's just say even factorial, so I'll put even factorial there, okay? So 2n even factorial, which means 2n times 2n minus 2 times 2n minus 4, etc., all the way down to the last one you'll multiply is 2, okay? Right, if you want that, that's going to be equal to the n factorial times 2 to the power of n. The reason being that n factorial is n times n minus 1 times n minus 2 all the way down to times 1, and all of these basically, to turn n into 2n, you need to multiply it by 2. To turn n minus 1 into 2n minus 2, you need to multiply it by 2, so times 2 times 2. All of them, to turn n minus 2 into 2n minus 4, you need to times it by 2, and all the way down to 1, to turn that into 2, you need to times it by 2. So how many times 2's are you going to have to times it by? You're going to have to times it by 2 to the, well, n of them, so times it by 2 to the power of little n. Okay, so that is the even factorial. So now if we want the odd factorial, so if you give me m, which is an odd number, and you want the odd factorial, then I need to take m factor, if I want, so I'll write it down here. So if I want m, and now I'll put odd factorial, okay, which means, well, it means this up here. So for 7, this is the example, 1 times 3 times 5 times 7. Then what I need to do is take m normal factorial and divide it through by the odd number subtract 1, so m minus 1, even factorial, because if m's an odd number, then m minus 1 is an even number, so I can take the even factorial of it, and now I've got the formula for even factorials. That is equal to the top is still m factorial. Now this bottom, m minus 1 is now taking the place of 2n, so I need to put in m minus 1 over 2. That's fine because m minus 1 is an even number, so I can divide it by 2, take the factorial of that, and then take 2 to the power of m minus 1 over 2. Okay, so that gives me the formula for the odd factorial. So now, if I want to complete my discussion of the gamma of m over 2, where m is an odd number, so gamma of m over 2 and I'll move this up and move this up. Okay, so gamma of m over 2, where m is an odd number, so 1, 3, 5, 7, 9, 11, etc. That's going to be equal to this m odd factorial in the numerator, so it's going to be equal to this formula here, m factorial over m minus 1 over 2 factorial times 2 to the power of m minus 1 over 2. And then what we've got to do is, you've got also 2 to the power of m plus 1 in the denominator, so times 2 to the power of m plus 1 over 2, and then you've just got times the square root of pi in there. Now, just combine these two together, which will work now quite nicely, and we get that this is going to be equal to m factorial remains in the numerator. You've still got over m minus 1 over 2 factorial, and now combine these two together. The minus half cancels with the plus half, and the m over 2 plus the m over 2 makes me just m. So I get 2 to the power of m, and then the square root of pi, like that. And that overall is a nice formula for what gamma of m over 2, where m is an odd number, is going to be equal to.